what we're going to have a look at in this lecture is the solution of quadratic equations. Okay, so quadratic equations are always in this form. Okay, so we've got an x squared there, an x and a number. So they can vary slightly. We'll see various types of quadratic equations, but generally they're in this form. Okay, so a, b and c, a being the coefficient of x squared, b being the coefficient of x, and c being the number on the end. Okay, so it's very important here that a, b and c can be any number, but a cannot be equals to 0. Okay, because if a was equals to 0, it would take this x squared out of this equation and we would just have a linear equation. Okay, so it's very important that that a is non-zero. They can be decimals, they can be negative numbers, fractions, but this a cannot be 0. Okay, so there's multiple ways that we can solve these quadratic equations. We can do it by what we call factorizing. Okay, factorizing, so this is introducing brackets. We can do it by using the quadratic formula. Okay, so you might have seen this formula before. Okay, we've got x is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so a, b and c relating to these numbers here. So we'll get into solution by the formula later on. Quite straightforward. It is just a case of substituting numbers in. We can also do this graphically as well. Okay, so in other words, drawing this quadratic function on a set of axes, okay, on a graph. So a quadratic equation, if we were to just quickly draw a graph out, it would look a little bit like that. Okay, so quadratic equations always have this wavy function. Now what we're doing when we're solving a quadratic equation is we're finding what we call roots to the equation. Okay, roots to the equation. Now what these roots to the equation are is where these this function crosses the x-axis. Okay, so for example, we could have two roots there, say 2 and minus 3, for example. Okay, so this is what we're doing when we're trying to solve a quadratic equation. Various methods as I've listed here. Factorizing is a little bit of trial and error. The quadratic formula is just a case of substituting numbers in. I won't go through the graphical part of it at the moment, because when you're drawing these functions graphically and trying to solve them graphically, of course it all depends then on how accurate you've plotted this graph. Okay, so it is just an approximation when you draw this graphically. Of course, if you draw it perfectly, then you will get the correct answers, but that's very difficult to do so. So a straightforward example then of a quadratic equation is something that looks a little bit like this. Okay, so we've got x squared plus 5x plus 6. So if we were to solve this then by factorizing, now these can be straightforward sometimes and they can be quite difficult depending on the numbers that we've been given in this quadratic. Sometimes they can be impossible to factorize, and then we need to look at the quadratic formula. Okay, so how do we start to factorize something like this then? Well, first of all, we've got to remember the form of a factorized quadratic. Okay, so a factorized quadratic will always be two brackets. You'll have a term here, 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 and here, and you'll have pluses and minuses in the middle. Okay, so we want to think now, how can we fill this up? Just by looking at this, how can we fill these brackets up with terms? So we've got all positives here, so we don't have to worry about any negatives being in the middle of these brackets. Okay, so as we've got all positives, we can fill in the signs in the middle with a plus and a plus. Okay, there are a few tricks when we've got negatives inside this quadratic to determine which signs we've got in the middle, but for now, as we've got all positives, we don't have to start thinking about negatives yet. And we always start off then with an x and an x. Because remember, when you have factorising a quadratic and factorising anything in general, if you multiply your brackets out, you should get what you started with. And that's a nice way that we can check that we factorised a quadratic. Now, in order, of course, to get the first term in this quadratic, when we're multiplying this out using the FOIL method, we need to multiply this term by this term. Okay, so of course now, to get an x squared, we need to multiply the x by an x. So that's how we start off. Now we need to think about which numbers do we put here and here. Okay, so looking back at our quadratic then, there's a little trick that we can use in order to fill these numbers in. Now looking at the quadratic then, these two numbers here are very important in aiding us to solve a quadratic. And what we've got to remember is that these two numbers that go here and here have to multiply to give this number on the end and add to give this number in the middle. Okay, so they've got to add to give 5 and multiply to give 6. So hopefully it's fairly straightforward which numbers we put in there, straightforward to you. But let's just look at this 6 on the end here. Numbers that multiply to give 6, well, there's a couple of options, aren't there? There's 6 and 1, and there's also 2 times 3. Okay, so there's a couple of options there for numbers that we could multiply to give 6. But of course, there's only one combination here that gives us 5 when we add them. Yeah, so if we add them, remember they're supposed to add up to give this number here. When we add these two, of course, we get 7. But if we add these two, we get 5. Okay, so that's what we did have in the middle here of that quadratic. So therefore then, 2 and 3 multiply to give 6, and they add to give 5. So we can put this 2 and 3 in here, and we factorise that quadratic correctly. Okay, it doesn't matter which way round you put this 2 and 3, of course, because when you multiply things together, it doesn't matter which way round they are. Okay, so it's called commutative law. That's the posh term for it. So in order to check this is correct then, remember we can use FOIL method. You don't have to do this every time, obviously. But for the more difficult ones, it is important that you multiply them out because it is a bit of trial and error. So if I multiply these out then, what do I get? If I do it quickly, x squared plus 3x plus 2x plus 6. Add these two in the middle and we'll get 5x. Therefore, we factorise this correctly. Okay. So, of course, we've just factorised this now. We haven't solved it yet. And in order to solve this, what we do is we split these two brackets up and we put them both equals to 0. Okay, so we've got x plus 2 is equals to 0 and x plus 3 is equals to 0. And now what we've got are two linear equations, straightforward to solve. We just need to take these numbers to the other side and we get x is minus 2 and x is minus 3. Okay, so these two numbers here now are what we call roots to this quadratic equation. And if we were to see what this looked like on a graph, so we got x and a y-axis, it would look a little bit like that. Okay, so we've got minus 2 here and minus 3 here. Okay, so this has just shown us now where this function crosses the x-axis, and it crosses it at minus 2 and minus 3. So just to have a little go at two very similar examples, okay, where we've just got positive numbers. in front of the x and on the end. Okay, so let's have a look at this one first then. So we recognize it's a quadratic. So it's going to be in this form. We're going to have an x and an x because we've got an x squared, plus and a plus because we've just got positives in the equation. And now we're looking for two numbers, if you remember, that multiply to give this 15 and add to give the 8. Okay, so think of a few numbers that add to give 8, multiply to give 15. The way that I start these off generally is I think of numbers that multiply to give 15 because there's less options for that than numbers that add to give 8. Yeah, you could do 1 plus 7, 2 plus 6 and so on. So numbers that multiply to give 15, so we could do 1 times 15, but they don't add to give 8. 5 and 3, so they multiply to give 15 and they add to give 8. Okay, so we've got 5 and a 3. Remember how we solve this then? Put both of these brackets equals to 0. And then solve these individually. So we've got x is minus 5 and x is minus 3. Okay, so these are roots to that equation. Moving on to the next one then, and feel free to pause this if you want to have a go before I crack on with it. Again, it's a quadratic. We know a quadratic will be in this form when it's factorized. Plus and a plus because we've got positives in there. Numbers that multiply to give 14, add to give 9. So multiply to give 14, add to give 9. Let's have a think. 7 and 2. Okay, so they multiply to give 14, add to give 9. Solve these separately. So we've got x plus 7 equals 0, x plus 2 equals 0. So x is minus 7 and x is minus 2. Okay, so these are the two roots to that equation. Okay, so whenever you've got a quadratic with both pluses here and here, always remember this is how it's done. Factorize it like this: x and an x, plus and a plus. Both of these multiply to give this number and add to give this number. Okay. Okay, so moving on to ones that are slightly more complicated then. So looking at this quadratic, we can see that it's slightly more complicated because we've got this minus here. Okay, so in the previous ones we just had all positives, so we didn't have to worry about any negatives. Here we've got a negative. So how do we start this off then? Well, there's a little trick in order to help you to start filling in these brackets in terms of which signs you put in there. What you've got to remember is if this is a minus here, okay, so if this is negative, then signs in the brackets, squeeze that in, signs in the brackets are different. Okay, they're different. So in other words, we'll have two brackets, so it's quadratic, so that it's laid out in exactly the same way. We've got an x and an x, because we want to get this x squared when we multiply them back out. And because this is a minus, the signs are different. Okay, so they've got to be different because remember, in order to get back to what we started with when we're multiplying this back out, to get to this number here, remember we multiply this term and this term. Yeah, we multiply the terms on the ends. Now, in order to get a negative, of course, the only way we can get a negative from multiplying two things together is if we've got a positive and a negative. Yeah, so this is why we've got to have separate, different signs. Now, it's the same thing in terms of multiplying to give the number on the end, add to to give the number in the middle. But of course it matters now which way round these numbers are. Yeah, so these brackets aren't exactly the same. In the last few examples, we had x plus something and x plus something. So therefore, it didn't really matter which way round they were because they were exactly the same. Here it does matter. So we're thinking of then numbers that multiply to give 8 and add to give 7. Okay, now remember when you're adding these two together, of course, if one is negative, when we add a negative, you end up with subtraction. Yes, so remember different signs, you end up with a subtraction. So numbers that multiply to give -8 and add to give positive 7. So numbers that multiply to give 8 then, we've got 8 and 1, 4 and 2. So neither of those are going to add to give 7, but of course now one of these is going to be negative. Okay, so have a think, which way round should this be? Should we have the 8 here and the 1 here, or the 1 here and the 8 here? So it's a little bit of trial and error. If you can't see it straight off, it is a case of sticking the numbers in, multiplying it back out. Did you get what you started with? If yes, then great. If not, you need to switch the numbers around and try again. Okay, so let's go for then a +8 and a -1, and we'll see if that works. Okay, so the only way to check is by multiplying it out. So what have we got? X squared minus x plus 8x minus 8 equals 0. And if we add these two together, so you've got -x plus 8x, that will give us our 7x minus 8 equals 0. So we factorize that correctly. Okay, so this is how we check if we factorized it correctly. If we did put the numbers the wrong way round, so say we had a 1 here and an 8 here, we'd get very close to what we've got at the start there, but not exactly the same. So if I just multiply this out now, say we guessed this incorrectly, x squared minus 8x plus x minus 8 equals 0. And what do we end up with? Look, x squared minus 7x minus 8 equals 0. So can you see we've got this bit right, but we've got a minus there. Okay, so we haven't factorized that correctly. So let's go back then to the correct factorization. So what was it? X plus 8 and x minus 1. And in terms of solving the quadratic then, exactly the same as we did previously. X plus 8 equals 0, x minus 1 equals 0, and solve these linear equations separately, and we get x is -8 and x is 1. Okay, so those are the roots to that equation. So slightly more trickier, a bit of trial and error, but very similar to the ones where you've just got positives. And just to add on to what we wrote down earlier, if this is a negative on the end here, then both signs in the brackets are different. Also, if this is positive, okay, so if this is positive, then the signs in the bracket, okay, in the brackets, are the same. Okay, so if the sign here is positive, then the signs in the brackets are the same. Okay, so just like in the last questions that we were doing, when we had a positive here, of course, we had a plus and a plus, because when you multiply these two together, then you end up with the positive on the end. But also, we could have two negatives. Okay, so if this is a positive, then these could also be two negatives. So you might think, well, when we were doing all positives, then why weren't we putting negatives in there instead? Well, what you've got to remember is when this sign is a positive here, then both of these signs here are always the same as this sign here. Okay, so when this is a positive, these signs here are always the same as this sign here. Okay, so on the easier ones we were doing earlier, we weren't putting negatives here because, of course, when you add these two together to give you this number here, if we're adding two negatives, we're going to end up with a negative. Yes? So when this is all positive, we don't need to worry about negatives, okay? But when this is a positive on the end here, both of the signs are always the same as this one here. Let's try one more quadratic then that looks very similar to the last one that we did. Okay, so remember it's quadratic, so we've got it in quadratic form, like this when we factorize it. Looking at the signs here, of course, we've got a minus there. So if you remember, it means we've got a plus and a minus. And it doesn't matter which one you put the plus and minus in, okay? But what does matter is that you've got the correct number by the correct sign, okay? So, you know, I could write this down like this if I wanted to. Okay, exactly the same thing, but it matters which number we've got by which sign, okay? So that's important. So thinking again then of two numbers that multiply to give minus 20 and add to give 8. So let's have a think. How about 10 and 2? So they multiply to give 20, don't they? 10 and 2, they multiply to give 20. But of course now they've got to add to give 8. So which one should we have as the minus here? If we had this as the minus, then if we add those two together, what do we get? Minus 8. Is that what we've got here? No. Okay, so therefore then, the only other option is to have the minus 2. So if we add those two together, we do get a positive 8, yeah? 10 minus 2. So going back to our factorized quadratic here, we want to have 10 as the positive and 2 as the negative. And again, you can multiply this out if you want to, and you should get what you started with. So if we do it quickly in our heads then, x squared minus 2x plus 10x. So you've got minus 2x plus 10x gives you the 8x. 10 times minus 2 gives you the minus 20. Okay, so we factorize that correctly. Split these up and solve them. And our two roots to the equation then are x equals minus 10 and x equals 2. So next example then to have a look at, we've got x squared minus 7x plus 12. So this looks slightly different now to the last couple we did. Notice this time we've got a plus here and we've got a minus here. Okay, so that will now affect us entering these signs into these brackets. Okay, so remember the little trick that I said? Of course, we've got x and x first to give us the x squared. But remember the trick I said that if this is a plus here, then both signs are the same as this sign. Okay, so if that's a plus there, both signs are the same as this sign. So we've got minus and minus in the middle. So it's just a nice little trick in order to help us to start filling in these brackets, because once we've put these signs in here, that's half the battle really. Okay, now we need the other half of the battle, which is which numbers do we put in. So we're looking for numbers now that multiply to give 12 and add to give minus 7. So slightly easier here actually because they're the same signs. And of course, because they're the same signs, it doesn't matter then which way round we put our numbers. Yeah, because when we multiply them out, you get exactly the same thing. So numbers that multiply to give 12, add to give minus 7. Have a think. 4 and 3. Okay, or minus 4 and minus 3. If we multiply minus 4 and minus 3, we get positive 12. if we add minus 4 and minus 3. So we've got minus 4 plus minus 3. Of course, that will give us a minus in the middle then. Minus 4 minus 3 we get as minus 7. So we factorise that correctly. Okay. Usual thing then, put both brackets equals to 0. And solve them. And we get our two roots to this equation as x is 4, positive 4, and x is 3. Another quick example then that looks fairly similar to the last one. So we've got x squared minus 5x plus 4. And again, feel free to pause the video if you want to have a go at it first. We've got x and an x. Of course, positive here, so it means both signs are the same as this sign. So we've got x minus something and x minus something. And now we're looking for numbers that multiply to give 4 and add to give minus 5. X minus 4, x minus 1. So if you multiply it out, x squared minus x minus 4x will give us minus 5x. So that's correct. Minus 4 times minus 1 will give us a positive 4. Okay, so let's solve these then. And again, we get the two roots to this equation as x is equals to 4 and x is equals to 1. Okay, so moving now on to the quadratic equations that are slightly more difficult. Okay, so what makes these a little bit more difficult, and particularly the one that I'm looking at here now, is that we've got a number in front of this x squared. Okay, so that affects the method of factorising these slightly, and we'll see why in a second. So it's a quadratic, so we factorise it in the normal way. So we've got two brackets and two terms in each. Now remember when we had an x squared here, we needed an x and an x, didn't we, to multiply back out to get back to what we started with. In order to get 2x squared, of course, we need to multiply a 2x and an x. Okay, again, it doesn't matter which way around these are, but generally when you factorise quadratics that look like this, you put the one with the x with the number at the front, okay, but it makes no difference. And of course, if you had 3x squared, you would have 3x and an x. It gets slightly more complicated when you've got a 4x squared, because of course you could have a 4x and an x, but you could also have a 2x and a 2x. Okay, so this is where the trial and error comes in. Okay, so you've got to multiply these out, of course, to see if you get back to what you started with. All right, so we've got 2x and an x. Now, the tricks with these signs still apply. So we've got all positives here. So we've got a plus and a plus. And now we want to think of numbers that multiply to give this. And this is the only clue that we've got in order to start to fill these numbers. And why is that? Why don't they add to give this number as they have in the last few examples? Well, the reason being is these brackets aren't the same, are they? This 2x will multiply by this term here, but it won't multiply by this term here. Okay, so the little trick that they add to give this number in the middle here, so 11 in this case, doesn't work when you have a number in front of this x squared. Okay, so this is where the trial and error comes in. We are looking now then for just numbers that multiply to give 5. And of course these brackets aren't the same now, so it matters which way around we put these numbers. So it's either 5 times 1 or 1 times 5. Okay, so these are the only two numbers that we can multiply together to give 5. So which way round do we put it? So this is where the trial and error comes in. You do get a bit of intuition eventually with it, but it is a bit of trial and error. So let's start with 5 and 1 then. Just to check, if we multiply this out, what do we get? 2x squared plus 2x plus 5x plus 5. Is that what we started with? No. Okay, so we've got 2x squared plus 7x plus 5. It's not what we started with. So we haven't factorized this correctly. Okay, so we've got to go back to our quadratic now. And what can we change, of course? Well, we can change these two numbers around. Okay, so instead of having 5 and 1, we're going to have 1 and 5. Now let's multiply this out. 2x squared plus 10x plus x plus 5. And add these two together, of course, and you get 11x plus 5. Okay, so we've got what we started with, therefore we've factorized this quadratic correctly. Right, so that's the difficult part done. Now in terms of solving this quadratic, it's exactly the same as the easier ones. Okay, so we split this up into 2. So we've got 2x plus 1 equals 0 and x plus 5 equals 0. So this root comes out nice and easily. Here is a little bit more work, but it's still fairly straightforward. Take the 1 to the right hand side, becomes minus 1. And we get x is minus a half. Okay, so either minus a half like this or minus 0.5. So these are the two roots to this equation. A little bit more trial and error with these when you've got a number that's not 1 in front of the x squared. Another similar example to the last one then. So let's have a look. We've got 3x squared plus 14x plus 8. Okay, so let's factorize this then. We're going to have a 3x and an x, because we've got a 3x squared there. Both positives, because we've only got positives in this equation. Now we're thinking of numbers, if you remember, that multiply to give 8. So we've got a couple of options, haven't we? We could have 8 and 1, or 1 and 8, or we could have 4 and 2, or we could have 2 and 4. Okay, so, and again, it matters which way around these are. So this is where the trial and error is. You stick these numbers into here and multiply it out. Hopefully you get back to what you started with. Okay, there's no quick way around it. Okay, so I'm not going to waste our time by going through all these options. Let's try this one at the bottom here. Okay, so this is the only combination that you can put into this and end up with what you started with. So let's put 2 and 4 into this. And let's multiply it out just to see if we get what we started with. So what do we get? 3x squared plus 12x plus 2x plus 8. Those two will give you 14x, so we factorized it correctly. Okay, so let's solve this. We've got 3x plus 2 equals 0, x plus 4 equals 0. Therefore 3x is equals to minus 2. X is then minus 2 over 3. And this one's a bit easier. We've got x is equals to minus 4. Okay, so there's the two roots to this equation, minus 2 over 3 and minus 4. So let's have a look at another example then where the coefficient in front of the x squared is more than 1. So the difference here, of course, is that we now have negative numbers involved in this as well. But the trick that we went through earlier still applies, okay? If we've got a minus here, then the signs in both brackets will be different, okay? Now, the difference being with this though, is that because these brackets aren't the same, because you've got a 2x here and an x here, it matters which way around they are, okay? So it could be a plus here and a minus here, or the other way around. We're still looking for two numbers though that multiply to give this 3 on the end. Okay, so it's going to be 3 and 1. Okay, so they're going to multiply to be minus 3. So if we bring some signs into this, it's going to be 3 and minus 1, or it could be minus 3 and 1. Okay, now on top of that, of course, is because these brackets aren't the same, this could be the other way around as well. So we could have minus 1 and 3, or 1 and minus 3. Okay, so there's multiple options here. Because these brackets aren't the same, it matters which way around the numbers are and also where the signs are. Okay, so it is a case then of trial and error. You've got to substitute these into this, multiply it out, and hopefully you get what we started with. Okay, so I'm not going to waste time in ploughing through all of these different options. So what we'll try is minus 3 here and a positive 1 here. Okay, so minus 3 and positive 1. So this was the correct solution. Okay, so you know it's luck of the draw to some extent. You could get this one as the correct one, you could get this one as the correct one. Okay, so this can be quite time consuming sometimes if you've got a tricky quadratic. Right, so let's well, we could multiply this out if we wanted to check. What do we get? 2x squared plus 2x minus 3x. So we've got plus 2x minus 3x. That'll give us minus 1x. Minus 3 times 1 will give us the minus 3. Solve this as normal again then. So we've got we've got 2x minus 3 equals 0. X plus 1 equals 0. 2x is equals to 3. So x is equals to 3 over 2. So that's 1 root. And a nice easy one here. Take this 1 to the right hand side and we get x is minus 1. Okay, so slightly trickier when we've got negatives involved in quadratics where the coefficient of x squared is greater than 1. It just gives us more options in terms of the trial and error aspect of solving these. Now, of course, we can have quadratics that look slightly different to the ones that we've seen so far. So if you remember, something is in quadratic form when it looks a bit like this: ax squared plus bx plus c. And also, if you remember, a cannot be equals to 0, because then we won't have a quadratic if we take out the x squared. But, of course, this b and this c could be equal to 0, because if we've got an x squared in there, it still means it's a quadratic. So in this case here, b is equals to 0. Yes, because we haven't got an x in there. So we've taken out the x, but it's still a quadratic because we've got this term here. Okay, we've still got an x squared. And we can solve this by factorizing again. So there's a specific method for factorizing something like this, and it's called difference between two squares. Okay, difference between two squares. And we'll see why it's called that in a second. These are very easy to factorize. So we remember it's a quadratic, or recognize it's a quadratic at least. And we've got an x here and here to get the x squared. Now the trick is, what you've got to remember, you've got to look at this first and recognize that it's difference between two squares. Okay, and that'll always be something squared minus something squared. Okay, so this is where the difference between two squares names come from. You've got a square, and we've got a square, and we've got a minus, so we've got a difference between something. Okay, so that's the first hurdle. You recognize that it's difference between two squares. We factorize it as normal, two brackets, x and an x, and we always have a plus and a minus. Okay, we'll see why in a second, but always got a plus and a minus, and the number that goes here and here is always the same as the square root of this number. Okay, so when I say the square root of this number, of course I mean the square root of 25. We don't look at the sign. Okay, so square root of 25. You couldn't take square root of minus 25, of course, because you can't take a square root of a negative number. Okay, so 25 is a square number, of course. 5 squared gives you 25. And this is x squared minus 25 factorised. If we multiply this back out, of course, we get x squared minus 5x plus 5x minus 25. And look what happens to the 5x's in the middle. They'll cancel. So we're left then with x squared minus 25. So we factorise that correctly. Okay, so we solve this normally now. So we've got x plus 5 is equal to 0. X minus 5 is equal to 0. X is equals to minus 5. X is equals to a positive 5. Okay, so those are the two roots of that equation. Of course, we could solve x squared minus 25 just normally rather than factorising. We could take the minus 25 to the right hand side, and then we could take square root to both sides. Okay, but you've got to be careful. Sometimes when people solve it like this, they always forget that when you take a square root, it's a plus and a minus a square root. Because remember what a square root is asking us. It's saying, what number do I multiply by itself in order to get this number underneath the square root? Well, we could multiply 5 by 5 to give us 25. Or we could also multiply minus 5 by minus 5. Yeah, like signs will give us a positive number. So minus 5 times minus 5 will also give us 25. So you've always got to remember, if you solve it like this, that it's plus or minus 5. People quite often forget about this plus or minus in front of the square root. It could be due to Pythagoras' theorem, where you're using square roots quite often. And of course, with Pythagoras, you're looking at lengths of triangles. Yeah, so generally you're looking at positives when you're looking at lengths of triangles. So that may be one reason. So let's have another quick look at a difference between two squares type of quadratic factorisation. Here we've got x squared minus 64. So we've got x and an x, plus and a minus, and of course the number that goes here and here is always the square root of this number. So what have we got? 8 and an 8, yeah, square root of 64. Split these up, and we get the two roots to our equation as minus 8 and 8. Okay, so fairly straightforward when you need to use difference between two squares.